I'm Jeff Deese. I've been with the fire department for 18 years. I've been a rancher in this town for all my life, and 5 generations before that, or 4 generations. In my 18 years in the fire department, it has been known that every one of these fires that I've gone to, whether chicken coop, barns, we've figured out what the cause and termination of the fire was. I would say out of that, 80% of it is basically on electricity. Out of those ones that are on electricity, probably 50% of them are people that don't know what they did because they just don't know that they did something that wasn't there. You have a whole string of outlets along a wall, and you go plug in 3 different extension cords, and you go plug in 4 different stock tank heaters. Those 4 outlets may be on the same circuit. So we're going to try to explain a little bit of layman's terms about basic electricity. So to get into the basics of things that happen, I've lived in the same house all my life. I've never had a fire in a barn or a house. This was almost the first. This stock tank heater was plugged in a week ago. We plugged it in. We got it, set it on a snowy bank. It was sitting right there. It was plugged into the wall. It pulled, and it pulled down. And if you don't think that an extension cord, when it's bent in half or pulled in apart, doesn't get hot enough to create heat, you can see in this one where all of the silicone burned out, and it actually burnt the plastic over here with the extension cord. It's no longer round, it's all long. I can pass this around if you guys want to see it. But that's what happened. When you take an extension cord and you do something like this with an extension cord or any type of cord, the resistive heating that goes around here is what's causing your heating, okay? That's one, resistive. Too much current being pulled through an extension cord before it will pop the breaker is the other, okay? So if we think about it, and I know that, like I said, I'm a licensed electrician, right? So I know how this all works. A lot of people take a stock tank heater, 1,500 watts. Almost 80% of your stock tank heaters are 1,500 watts. This one's 1,500 watts, okay? You can get some bucket heaters that are less, and it says that. But what does 1,500 watts mean? You're plugging into a 20 amp outlet. What does 1,500 watts mean? So watts divided by volts equals amps. Okay? So your wattage divided by your 120 standard household voltage gives you what your amperage is pulling, right? I left my notebook back in the back. It's like 12.5. Okay? That's 12.5 amps. And now you plug that into a wall outlet, and you run an extension cord 200 feet out to your barn so that you can heat up this stock tank heater, or better yet, this chicken coop heater, because we've had this happen already. Okay? You create even further, because as you get distance in it, you have voltage drop, and you'll create heating along that too. One rule of thumb that I've always said in an extension cord is go feel it, plug everything in, grab a hold of the extension cord. The telltale sign, whenever the snow's melting around it, it's pretty much got quite a bit of resistance in it that it's actually doing it. If it's doing its job, this extension cord can lie in the snow and you'll never know it's there. You take this extension cord, you plug it in, and you go plug it in your truck with a 4,500 watt heater, and you'll see the snow melt all the way to the plug that you just plugged in, okay? So heating. Heating is huge. How do we get rid of heating? If we have to go that distance, we need to increase our wire size. Everybody goes to Home Depot. Okay? The next thing, 16.3, 14.3, 12.3. What do these things mean? The size of the wire is the amount of current that it can carry. Okay? So I would say anytime that you're plugging in any type of stock tank heater, anything that's 1,500 watts and above, you need at least a 12.3 extension cord. What we find out is people do that, and then they take this extension cord, they take this divider, they take this little lightweight extension cord and plug in 3 more light bulbs. Okay? Now you're up over the limit of what the breaker is. So you're up over what the 20 amp breaker would allow that to be, or a 15 amp breaker, because that outlet in a residential situation is probably a 20 amp outlet unless it's in the kitchen, the laundry room, or the bathroom. And if the house was built before 1982, that doesn't apply either. So now you're talking 15 amps versus 20. Okay? So my recommendation to everybody is to add up what this says. So this is 1,500 watts, correct? If we go down here and we grab this heat lamp bulb because we want to keep our chickens warm, well, we're not supposed to do that. So we're going to keep our chickens warm. Now we're at 150. Okay? So we're going to add that up, right? Then we're going to put up a this is simulated 300 watt light bulbs, right? So we're at 15, right? 1675. We're at 1950, 1925 with this with 3 light bulbs, okay? So that's watts. Okay? Divided by 120. Okay? That circuit is overloaded as far as I'm concerned. Okay? That's all it takes to overload that circuit. Now if you go and plug this one into the outlet that's next to it, that's on the same circuit, you've overloaded it twice. Eventually the breaker's going to trip. Whenever it gets hot enough, it's going to trip. That's what breakers are designed to do. You can find out what the circuit is. Look on the front of the breaker and it tells you what the amperage is of the breaker, whether that's a 20 amp circuit or a 15 amp circuit or what that is. Okay, so very important to know that if you're plugging in numerous things on the outside outlet of your house, a lot of houses have 2 separate outlets on the house. They might have 2 separate circuits. Maybe you need to divide that up and go to 2 different places. The house that we almost lost on Soda Creek, same thing. We have way too many overloads. The other thing that we come up with a lot in barn fires, somebody takes that extension cord. I got an extension cord right here. Those are all. I do want to thank Big R just for doing this. Big R provided all of the stuff for us today. As far as we didn't have to go buy it, we didn't have to do anything. I walked in, they took care of it. The big thing that you find out in a barn is everybody says, okay, I got to go down to that stock tank heater and unwrap that around this beam right here a couple of times and bring it back down through here so the horse can't pull it out and tie a knot. Okay? You just created a great big resistive heater. All I did is heats all of this up. So whatever that's tied to, whether that be a wood beam or something like that, it's sitting there and starts heating up and heating up and heating up, and you don't realize it because that little spot right there is starting to burn a hole. We've got several barns like this. We've had a truck fire like this. The guy took the same thing in a truck, burnt the house to the ground, took it, stuck it through the tow hook, went back around, came back, tied it up so nobody would trip over that cord and pull it out of his truck. Caught the front of the truck on fire because of the resistive heating that was in the front of the extension cord caught on fire. Okay? So a lot to think about. I know that's a lot to be thrown at you, but think of one basic thing. That watts divided by volts, and you're not going to find, unless you get into commercial stuff, you're not going to find anything more than 120. All your lights are going to be 120 volt. All your heaters are going to be 120 volt. So watts divided by volts equals the amount of amperage that it's pulling. That has to be less than 80% of what this breaker is rated at. And I'll get this put down on a sheet and give it to the guys so that you guys can see it too. But that's the key. The key is you cannot go over 80% of what that breaker is rated for. So, in saying that, that means that anything else that's plugged into this circuit that's in your house, it counts for what that is. So if you go in and plug your chicken coop into it, or your horse barn, or your outside shed, I don't care what it is. I mean, all of it can get to the barn at some related ideas, right? So you take all of that and you've got to see what that is. Okay, you need to know how much is plugged into that circuit that you're sending out there. So the biggest, and seriously the biggest thing that I've seen in most of these is electrical. And I hate to say that because I'm an electrician. But I wire it to there. I don't, after what goes on after that, a vet clinic burned down in this town because somebody took an extension cord and ran it underneath of the throw rug and burnt down a vet clinic in this town for that reason. That's what happened, is because they got it underneath of the throw rug, and between the walking on it and the friction and the heat, because an extension cord is made to radiate heat away from it, you start holding it together, it starts creating heat. Right? Okay? Does that make sense? Okay, so you can go to lighter. You can have bucket heaters. There's bucket heaters. There's all kinds of different heaters. Just make sure, again, this one doesn't pull as much. I can't remember what this one is. This is 4.2 amps. It said right on it. Versus 12, okay? And some odd amps, okay? So you need to do that. The other thing you need to think about is a GFI. A lot of these would have been handled if they would have put a GFI in that circuit. A GFI is a ground fault circuit interrupter. It measures milliamps in between neutral and ground. A breaker realizes fault between ground and neutral. So as long as there's no fault, it just keeps sending more power out there until it heats up enough that it faults. But a GFI, why they have them in your bathroom? So your wife can't throw the hairdryer in the bathtub while you're sitting in it. It won't work anymore. That doesn't work anyway. We've proved it several times. In the movies it works just fine, but it doesn't work. If the blow dryer will sit there and go until it burns up and that's all that happens and nobody dies in the bathtub. So we've taken meters, we've taken everything else and done it in several investigation classes. So, but I wouldn't try it. He might not like you afterwards, or he might not like you. One of the two, okay? Ground fault circuit interrupter. A lot of your places on your outdoor outlets. Well, any house built after 1974 has an outside GFI. You don't need two of these. Don't put two of them in a row. More isn't better. One works just as well as two, and two doesn't work as well as one. It doesn't work the same. We do not put these in series or a barrel. They're single. So if you don't have one, you can buy one at Big R that you can plug into a non-GFI receptacle somewhere. Maybe it's in your garage, and you're going to go outside with it to a stock tank heater, and then you have a GFI. So the GFI will also protect a horse. And we talk about water. We talk about water to chickens. We talk about water to livestock. I've been raising livestock all my life. I know Shane says feed more. I feed more. I do things. There's things that we do different and everything else. But the one biggest thing that I have is water. Okay? And water is the key thing to any livestock. It's the key thing to yourself, right? So there's a couple things you need to keep in mind whenever you put that stock tank heater in that stock tank, or that heater in that water tank for chickens or pigs or whatever. Make sure it's grounded, that it has a ground prong on it, and make sure the outlet that it's going to is grounded. Okay? Because if this heater faults, that horse just became the path between that water tank, through his body, through his nose, to his feet, became ground. Okay? It hasn't happened. It used to happen a lot in the older heaters. I think it happened more before they made these auto shutoffs if they run out of water. And then they'd burn up and they'd fault. And then you'd fill it back up. That horse would walk over there in a non-grounded situation, stick his nose in there, and get zapped. And you wonder why your horse hasn't drank any water in a week. Or if you walk over and stick your finger in there and reach over and touch the barbed wire fence, you'll figure out real quick why it happens. Okay, so a grounded circuit is very valuable. It has to be a grounded circuit, or this tank heater faults, that horse is the path to ground. Electricity has one thing. Its only mission in life is to find ground. And you learn that more in bigger electricity, but that's the only path it has. So if this is faulted, and it's sitting there, and it's sitting in that water, and it's trying to find ground through the water, which is a great conductor of electricity, as soon as that horse or that chicken or anything touches it, its feet to its nose becomes the path to ground. Okay? So a grounded circuit is probably one of the most important things I can think of in a stock tank heater, in any heater or anything else like that that can be touched by the animal that would be able to do that, okay? And even these small ones are grounded. They're all grounded for that reason. Because if they do not ground them, you don't want to be the horse that touches it. Like walking over and grabbing hold of a hot fence, you don't really want to do that. Okay, multi-plugs. This is what I'm talking about. You plug one of these in, you plug 3 more things into it, you got to add up everything that you plugged into here. It's not what plugged into there, it's what plugged into here and what's plugged into the wall. Okay? I can't stress that enough because we've burned down a lot of houses. We've burned down a lot of things before that we can find this in. I'm not a big fan of lots of these. Matter of fact, I'm not a big fan of them at all unless you have your chargers to the wall grill plugged into it or something that doesn't pull anything. Or no LED Christmas lights. 14 3-gate extension cords. That's the cheapest, most common you'll find. Great for a light bulb, not great for a water heater. Okay? The other thing I want to talk about quite a bit, and this has happened to us, the rating on the box tells you exactly where it's supposed to be, where it should be. This one right here explicitly tells you for outdoor use only in a dry covered area. Okay? We've had these fault in a chicken house because they have them outside Don't put the heat water in the barn, but make sure it's in a dry area, okay? Does that make sense? Follow what it says on here. Put it where it's supposed to be. Heat tape is the same way. You have heat tape for your pipes, your wires, your everything else, your water pipes, whatever. Some heat tapes are rated for indoor use. Some heat tapes are rated for outdoor use. They need to be UV protected if they're for outdoor use, or they will fault and fail too. They'll crack and crumble up. We had a structure fire because of this. Because they did not use the right heat tape that was for the area that they were doing. They were using a heat tape that was for underneath the house to do pipes or something like that. They actually were using it on the roof. It only took a little while for it to deteriorate and fail. So it's very important to use what they say to use and use it for what it says to be used for. Okay? On this it says that it's thermostatically controlled, and it also says that you need to keep it in a clean, dry area. Well, how the heck do you keep it in a clean area in a chicken house? So you got to think about, you might not want to get this all mounded up with chicken manure all the way around it, or whatever, to the point where that heat can't dissipate from where it's supposed to. Because then it becomes your hot plate at your house. And then the stuff that touches it will be on top of that hot plate. Okay? Here are three, pretty much, of the exact same idea. Okay? On every light fixture in your house, on every light fixture that you buy, by law, has to be a stamp on the inside of it. And it tells you what the maximum wattage of volt you can put in. And the reason it tells you that is because this fixture is not made for you to put this 300 watt light bulb in. This fixture is made for a 90 watt light bulb max. It's not even made for a 100 watt light bulb. This fixture right here, I think is, this one right here will go to the 125 for the heat lamp, okay? But it will not, again, accept this 300, nor will this one. So there's a lot of ways, I mean, in the cattle business and everything else that I've been in, there's a lot of times that we put these in barns and put as much as we can to them to keep the calf dry. Because a dry animal is a live animal in my world. If they're dry, if they're born and you can get it dry, they'll stay alive. So whenever you think about that, you put as much as you can to heat and everything else like that. Well, things have changed a little bit from heat lamps. You can go to Big R and you can buy 4 heat lamps in one stick. And you can plug this in and create as much heat as a heat lamp. And you can hang this from a rod, you can hang this from a chain, you can move this wherever you need to, you can focus it down on an animal, you can do whatever you need to do. Okay? Much safer idea. It's guarded just like an electric heater. You can't burn yourself unless you physically stick your fingers plumb through it. Okay? And to say what that is, you can take a heat lamp and you can literally, and I did this for quite a while today, you can take that heat lamp and you can hold it in this whole thing hay. You can hold it right there in that bucket of hay. You can hold it as long as that bulb doesn't touch that hay. It very likely will not get hot enough to do that. As soon as I put that in there, and that falls down, therefore the reason I think this idea is better because you can secure it to where it's at. I don't know how many 2x4s I've ever clamped onto, and you clamp onto it, and all of a sudden this light's over here, or this light's down here, or this light's on the ground. And if this light goes to the ground, it's going to do the same thing that is. It's going to catch on fire. Because there's nothing to shut it off, because it doesn't have a tip meter in it like this heater does. It doesn't have any of that type of stuff. I don't like big electric heaters in barns just because I truly believe in what Shane says. In the 50 years that I've been raising livestock, if that horse wants to get in the barn, he can always get in the barn. And I have 15 head of horses that are standing outside the middle of the hayfield. They'll turn their butt to the wind and they'll stand there. Cows will do the same. They'll group up, they'll go in a tree, they'll do something else. But they do not like to be in a barn for some reason. And I think that's because they know what their protected blanket is, right? They know what their element is. I've never seen a dead horse in Wyoming. And there's a lot of horses in Wyoming that are living out in the middle of nowhere. We have a ranch up there, and we drive by them all the time. You can see it doesn't take very long. I don't want to set smoke detectors off, but it doesn't take very long for this thing to start on fire. That's all the longer that heat lamp had to fall on the ground. Okay, so it fell into a bucket of really nice hay, and it's on fire. Okay? All right, so keep that in mind, that securing whatever you put up is as important as what you're putting up, okay? I hate to say it, have an electrician come and wire your barn. That outlet over there may be worth, Shane, you set that light bulb outside too. That outlet that's over there, I can get 80% of it. When I put an extension cord and bring it over here, I only get 60% of it because that cord derated that outlet. So if you have stock tank heaters, you have water heaters, you have heaters that you want to plug in, then by far I would say the best thing to do is have an electrician come out and wire your barn where you're going to put a stock tank heater. Don't take and plug into that one and run an extension cord up and over and tie it to the rafters and come back down to create the issues that we've had. I feel very strongly about this because it's my livelihood, and I really don't like going and investigating fires in barns and chicken houses and everything else. We have to find out what's going on with them. We learn from it, and I think bringing it to the public is more important than keeping it in my head. So therefore, the reason why when Shane said he'd do this, I said I would do it too.